Let's begin. Today's November 4th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 5, 9, 13, 17, 19, and 22. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card B will take a look at our 3-digit solution, and the Turing Machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2, maybe even all 3 are 3. Criteria card C will take a look at our middle and last digits, square and circle, and compare them. So should the value of square be less than circle? Should they be equal? Or should the value of square be greater than circle? Criteria card D again takes a look at our 3-digit solution, but this time it'll let us know how many evens there are. Are there no evens? Is there a single even? Perhaps 2, maybe even all 3 are even. Criteria card E will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should the sum be equal to 6? Or should the sum be greater than 6? And finally, criteria card F will take a look at our 3 digits from triangle to square to circle, but this time it'll let us know something about the order of the digits. So the first case is that the 3-digit code may appear in an ascending order, meaning that they're increasing, as in the example 135, or the 3-digit code could be in a descending order, or basically decreasing, as in the example 421. And finally, the 3-digit code could have no order. So let's take a look at the example of 231. Notice that it goes from 2 to 3, which is increasing, and then 3 to 1, then decreasing. Of course, it could also be decreasing and then increasing, but it's that shift from increasing to decreasing, or vice versa. That's one way to define a 3-digit code to have no order. We've also seen in previous puzzles where if you have consecutive equal digits, that also exhibit no order. So for example, let's take a look at the example 331. There is no change between 3 and 3. So that second option of consecutive equal digits is also another way to define a 3-digit code to have no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card A. Okay, so the Turing Machine does not approve of my choice for triangle. I did pick an odd 3, but the Turing Machine does not agree with that. So it's letting us know that the triangle digit should actually be an even digit. So let's go ahead and type that up in our notes in section A. And we'll say that triangle is an even digit. And of course, since it is even, let's go ahead and cross out the 3 odds. So crossing out 1, 3, and 5. Okay. Of course, we do have this criteria card that lets us know how many evens there are. Let's see. So obviously there can't be 0 evens because We already established triangle to be even. Also, I don't think you could have 3 evens, because if you had 3 evens, you know there'd be 0 3s. So making this card irrelevant. So it really comes down to either having 1 even or 2 evens at this point. So that may not be such a bad option. Yeah, let's go ahead and test criteria card D. Okay, so it does not approve of my choice of a single even. Therefore, I think I'm going to type it up as we're going to deduce that there should be actually 2 evens. We'll say that the solution has 2 evens. Okay, so of course it can't be 0, it can't be 3, and it did not like the fact that we only had 1. So therefore we do have 2 evens, and of course there's an odd in the mix, which means that one of square or circle is even and the other is odd. So, which is pretty good, because we know from criteria card C there's no way they could be equal. The middle and the last could not be equal. So that's helpful. What about the number of 3s? So yeah, so the criteria card B boils down to, well, there is a 3 or there isn't, but because we have an odd, we know it's going to be 1 or 5. And we do have a 3-digit in there. Let's see. But I think what I'm going to do is I think I'm going to test criteria card E. Okay, so the Turing Machine does not approve of my choice for triangle and square. Notice that for criteria card E, we are adding the digits. So let's add 3 and 1, that's 4. 4 is less than 6, but the Turing Machine does not approve of that. So that means that the sum of the first 2 digits must either equal to 6 or be greater than 6. So let's go ahead and type that up in section E. And of course that again is that triangle plus square should be either equal to, let me just adjust this a bit, should be equal to or be greater than 6. Okay, so, well, let's see, can we say anything about that? Well, I think the fact that it could equal 6 means that, yeah, we can't really cross out anything, specifically 1s or 5s. So, so let's see, can we make any other kind of conclusion? Yeah, I don't think so. Interesting. Okay, well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card B, establishing how many 3s there might be in our solution. As we stated earlier, it's either there or it's not. And if it's not, it's going to be 1 or 5. We also did not test or compare our middle and last digits, square and circle. And again, we also established that between square and circle, 1 is even, 1's odd. So obviously they can't be equal to each other. And we also did not test criteria card F, the ordering of the digits. Now, if you've listened to these videos in the past, I believe we may be able to deduce what the order might be, specifically with the assistance of criteria card C. So I think the argument goes as follows. If the 3-digit code, if it happens to be in an ascending order, meaning that the digits are increasing, we would know that square should be smaller than circle, making this card irrelevant. And similarly, if the 3-digit code would be in a descending order, well, that would mean that square would be larger than circle. Again, making this card irrelevant if you knew that either was ascending or descending. That would reveal what basically C is testing, making it irrelevant. So at this point, I think I'm going to say that we're going to deduce that the solution has no order. Okay, so we are looking at a 3-digit code that has no order. Okay, well, let's see, what else can we do? Well, we do know that there's going to be an even among square and circle. What if it were square? Now, we don't know if the two evens are identical or, different. In the case where perhaps maybe the sum is equal to 6, we would know that there would be a 2 and a 4 in some order, making circle the odd digit. Okay, so that is a possibility where, it could be something like 2, 4, 3 or 2, 4, 1, or it could be 4, 2, 3, 4, 2, 5. So it could be that square might be either less than or greater than square, or I should say square is less than or greater than circle. And that would in some way inform us of what triangle and of course square would be. So yeah, and that's if the sum is equal to 6. That's very likely. So, well, let's give that a try. Let's say it's going to be 4, 2, 4, 2, 5. Let's try that out. Okay, 4, 2, 5. That looks good. Okay, so of course the whole purpose for this proposal is that the sum is equal to 6. So let's go ahead. Let's see, I always ask, can we deduce certain things? Well, we already deduced F, which is great. Yeah, let's go ahead and test criteria card E again, establishing if the sum is actually 6. Okay, so the sum is not equal to 6. Very interesting. So let's go ahead and cross out the equal here. And so that would mean that the sum must actually be greater than 6. Okay, so at this point then, we know that square cannot be a 1. Well, let's see. Yeah, the square cannot be a 1 because if you add it to either 2 or 4, that'll never get us to be greater than 6. So square cannot be 1. And similarly, I don't think square could be 2 because, again, 2 plus 4 is still 6, still smaller. So that cannot be the case. Okay, but 3 can be added to 4. That's a possibility. And triangle 2 can be added to 5. Okay, let's see. Yeah, again, we can't really say that the the two even digits can't be equal. There's nothing in here that says it can't. So it's not like we can cross out 2 and 4 because, oh, well, they add up to 6. That's not possible. This 4 may still add up to 4 here. Okay, let's see, anything else? Let's see. Yeah, I think that might be it for that. So the next thing, let's actually test criteria card B, the number. Let's see, number of 3s. Can we do that? Or should we test criteria card C? Well, it would be interesting if there were or weren't a 3. You know, you only have 2 3s left, and you technically only have 3 other odds left. So let's go ahead and test criteria card B. Okay, so it does not approve of the fact that there is no 3. So it doesn't like that there are 0 3s. Okay, so that means that there is a 3. Very interesting. Okay, so B, let's go ahead and type up, and we'll say, well, we're going to deduce that so that the solution has a single 3-digit. Okay, so there is a 3. So let's go ahead then and cross out everything that's odd and not a 3. So square can't be 5, and triangle can't be a 1 or 5. So very interesting thus far. Okay, now do we have enough to deduce what C might be? Remember, they can be equal because we do have an odd. So can we deduce that maybe square is going to be bigger? Well, let's do this. Again, based on that, I don't think circle could be 4. Well, no, that's not true, because it could be 3, 4. Yeah. Let's see. We know they can't be equal. Yeah, there are cases where square is bigger and where square is smaller, technically. Okay, so we know, okay, so now though, this is interesting. Now we can actually cross out triangle 2 because at most it'll be equal to 6, because if we add 2 and 4. Okay, so we have just revealed what triangle is. Okay. So we know there can't be 3 4s. So the question is, can it be 4 4 3? Yeah, I think it almost comes down to only 2 possibilities. Either, I guess let's do it in order, and we'll type it up in C. So either the solutions could be 4 3 4, it can't be 2 because it's supposed to have no order. It can't be 4 3 3 because there's supposed to be two evens. So that means it would have to be 4, 3, 4. And then otherwise it would be 4, 4, 3, because again you do need a 3. Okay, yeah, and in both of these cases they are different. Notice that in the first case our square digit is smaller than our circle digit, and of course vice versa. In the second potential solution, square is larger than the circle. Square 4 is bigger than circle 3. And yeah, I don't think there's a way to deduce that. So let's go ahead and test criteria card C. Yeah, luckily I do have, obviously one of those cases. So let's test C. Okay, so it is not true that square is smaller. Since the Turing Machine does not approve that, it's saying that this is incorrect. So in fact, square should be greater. So let's put up here that again, we're going to deduce that square, let me get some space here. We're going to deduce that square should actually be larger than circle. Okay, so that would mean that it can't be 4, 3, 4. And so it looks like our solution should be 4, 4, 3. So let's go ahead and cross this out. Yeah, now 4, 3, 2. Yeah, 4, 3, 4. And 4, 4, 3. Yeah, that looks good. Okay, so yeah, it looks like our solution should be 4, 4, 3. Okay, so let's type that up. Okay, and let's just do a quick review. Is our first digit even? It sure is. We did deduce that the solution should have a single 3. It does. Again, we deduce that the middle digit should be greater than the circle digit. We deduce that the solution should have 2 evens. We did confirm that the sum of the first two should be greater than 6. They are. And we deduce no order. Lots of deductions, very interesting. And so let's go ahead and confirm it. Or let's verify. So 4, 4, 3 as our solution. So 4, 4, 3. Well, fantastic. Now, how do we do versus the Turing machine? Let's go back. So obviously the puzzle does have 6 criteria cards, and we actually did 6 tests. So that's always a good indication that at a minimum we tied. Hopefully maybe we did better. So we did do ADE in the first round, and then we did sort of the remaining BC. We deduced F outright, but we did do E twice. So it was ADE in the first round. And all were wrong. Very interesting. So ADE, and then the remaining 2 BC, and it was E, right? Yeah, E was the one that we duplicated. All right. Okay, so we beat the Turing machine by 1 question. So again, very interesting how, we had basically 4 deductions. Obviously, these X's eliminate all those paths that we should not continue with. So that way we modify our proposal at each stage. We do learn new information even if we get X's. And notice that this was one of those cases that I mentioned at the top of the video that could be a 3-digit code with no order, and that is that there are consecutive equal digits. So the 4-4 again does not exhibit any change, no growth, or it doesn't increase nor decrease. So again, another way to describe a 3-digit code to have no order. Well, what about you? How did you solve it? Hopefully you did get some check marks maybe along the way, that you had good instincts. Please share your gameplay in the comments. If you like the video, please do give it a thumbs up, and so that more people can find the channel. And of course, hit subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.